Hello, in this video, we're going to be working on completing the Module 5 lab. So let's read through the instructions. It says create a program that tracks UFO sighting for a work week, Monday through Friday. The program should ask the user for the number of sightings for each of the 5 days. The program should output the days sorted from least to greatest. Use parallel arrays to store the day names and sighting counts. Loop over the arrays to store user input and print output. All right. And after your program runs, it should look like this. Okay, so we have some stuff that we can copy in. But I see kind of the general goal here, and I'm hoping you guys can see it too. Right? I think this is going to be pretty straight ahead. So let's jump over to Visual Studio and start putting stuff together. Have a new program already opened up here and ready to go. And let's start with some basics here. So I heard the directive that they wanted us to create 2 arrays, one holding days of the week and the other one holding, well, sightings, the number of sightings, and we have to make that a certain size. So let's do these in 2 different ways. First, the first one is going to be a string array because the days of the week, those are names, right? So we'll just call it days. It'll be filled with strings. And you know what? I mean, these are really common. I don't want to have to create an empty one and then add values to it. I can just kind of pre-initialize it right here. So I can say Monday, comma goes on the outside, Tuesday, and Friday. Of course, we have a semicolon there. So I've created it and I filled it with values, right? All right, that's good. That's a good start, right? Then we're going to create an array that's going to hold the number of sightings. And, well, that's going to be whole numbers, right? I mean, somebody didn't do like half a sighting. They either had a sighting or they didn't. So it'll be an integer array. So I'll create one of ints. And let's just call it sightings. Now this one, I'm going to use the new declaration. I'm going to use the data type, and then inside the square brackets, I need to put inside here how big it should be. Well, I could just do this. I could look at the array above because these have to be parallel, right? And I could just go, I got 0, 1, 2, 3, 4, or if I count them, 1, 2, 3, 4, 5. So I need an array of size 5. I can just hard code it here. All right. And if you do that in your homework, I'm good with it. That's fine. Just want to give you an alternate thought though. If I want to make them parallel, and let's say I didn't know exactly how many things were in the days array, right? Let's say we had, 1,000 days with all the different names. Not happening, but I'm just saying, right? I could instead run days dot length, so I could just probe the other array for its length, pull back that value, and make this one the same size. So that's what I'm going to do. Right? Is it necessary? No, I could have hard coded it. Not a big deal. Okay, so I love how this already knows what I'm going to type in because this is exactly what I was going to type in. Now we want to traverse this, right? And a loop is a smart way to do it. And we want to enter the number of sightings for each day, right? So yeah, for int I equals 0, that's a good place to start. Are we going to run it up until the length of days? Yeah, 5 days. That sounds right. And increment 1 each time. Perfect. Thank you, Visual Studio, for writing my code for me. Right, I am thankful. I think a lot of old school coders like myself are like, hey, that's cheating. You're not learning anything. It's like, no, you're not making mistakes. That's what's happening. So now we're going to do a prompt, right? So let's Now let's just type this in, console dot write, and we're just doing a write here, right? Because we want it on the same line. And well, what are we going to write? Well, you know what? I want to think about this here for a second. We're going to prompt them to say, well, we're given the example, so we can actually copy it right from the example. Enter sightings on, well, every day it changes. So I could like, well, how do I do that? I mean, the only way that I can put this information in there is to read it from the days array and put it on the screen, right? So I'm gonna do string interpolation, I think is what I'm gonna do. So let's do it like this. I'm gonna drop in my $sign so I can do the string interpolation. Let's get the double quotes all the way in there and then say enter sightings on, well, we would say like which day, but we're going to read that in. Where are we reading that in from? From days and the current position, starting with Monday, so square bracket 0. Well, no, we don't want to hard code that. We want that to change dynamically. So we'll just put in the index variable there that will automatically change each time. Start at 0. So enter sightings on Monday is what that will say. And then we'll put in a colon and leave a space or two so that they have a little space to type. Right? Then, of course, we have to read it in. And we're going to store that in the other array, right? Whatever they typed in. So we're going to say, oops, let's spell it right. Sightings in which position? Position I. That's all correct. But what will that be equal to? This will be a read line. So we are going to convert, type it right, convert to int 32. And we're not going to do days sub I. We are going to do console dot read line empty parentheses. So we're just reading it from the keyboard, converting it to a number, storing it in whatever the current position is for sightings. First we'll do Monday, that'll go to position 0, and so on until we go all the way through. So there's the first loop. Now, it does also say, I don't want to read these instructions, use parallel arrays to store the day names and sighting counts. Okay, we kind of have that going. Loop over the arrays to store the user input and print output. So we're going to do another loop after. But didn't it say somewhere the program should output the days sorted from least to greatest? Okay, so all right, so we have to do a sort. And if you guys remember that sort method that we looked at, it goes kind of like this. We can do an array dot sort, and yeah, we'll sort sightings first, right? And then we'll sort days, right? So what we're really, in other words, what we're really sorting is the sightings, and then the parallel array of days will flip based upon that input. That's all there is to that. Not for, now we're going to do output, by the way, if you're wondering where I'm going here. Declare a new counter here. Now this automatically goes to I again, because that's just the most common thing to use. And now it's auto suggesting, and I'm not sure this is right, because I want to output what's inside each one of these things. And I'm going to look at the days and the sightings. Okay, these are parallel arrays. I could really run the loop compared against the length of either one. It doesn't actually matter. Because, and why? Because the length of each of these is the same. And I kind of wish it didn't take the auto type away, but it did. But I'm going to, in my solution here, I have this. I focused on the length of days as opposed to the length of sightings. However, logically think about it, you could use either one. It would actually work. Right? Because it's just really a value numerically. You could also hard code it, not recommended. So there's the for loop declaration. Now we're just going to do an output. So now it's just need clever output to output this. And the way the output should read is, I see. So we don't even have any preface text. We're just going to say Wednesday the number 2, Monday, the number 9, Tuesday, the number 19, etc. So in other words, they're sorted numerically, but they're displayed day and then sighting count. The other thing I'm noticing, and I'm not sure if you guys are catching this, but it seems to be also formatted. It's like, oh, great. So I got to go back and look up my formatting commands if you want. If you want to make them formatted, that would be nice, right? But let's begin by just getting them on the screen. All right, so here's how I'm going to do that. I'm just going to do a console write line. So there's declaration. I am going to use string interpolation. So I'm going to throw my $sign here. And then I'm going to go right into the double quotes. And I like to close my double quotes, by the way. This is just a hangover from Java, basically. But I'm going to, in the string interpolation here, I'm going to say days. Which one? Well, let's the first position, right? Keep in mind, it's sorted now. So whatever day it happens to be, it could be any of the days in this spot. And then from there, we'll output the sightings. So with that, we just say sightings. And which position? I, right? So whatever position we're currently remembering, this is sorted. So also need to close that out. Okay, so we're going to put output the days, and then we're going to output the sightings. Well, let's run this. This will actually run. This is all the code, by the way, believe it or not. Let's run it. Oh, and it says there's build errors. All right, so we got a problem here. All right, so let's figure out, no, we don't want the last successful build. We want the current build to succeed. All right. So it says on line 13, it says cannot implicitly convert type int to Boolean. Oh, I see. I'm missing part of my statement. Okay. So I forgot to put in I less than days line. Okay. But notice what I did. I didn't freak out to the error. I read it. I took a look. And then right away it appeared to me because I'm not like, well, I mean, it is kind of a Boolean value, right? Like that's going to be true or false, but it has to compare to something in order for it to work. Let's run it now. Okay, looks like it's running. Enter settings on Monday. And you know what? I'm going to borrow the values from here. So it's 9, 19, 2, 33, and 111. All right, now cross our fingers and hope it works. Wednesday 2, Monday 9, Tuesday 19, Thursday 30. Okay, it looks like it did it, right? Just the same way. It's got them in the same order, same output. The only difference is mine doesn't look as pretty because it's not all lined up, right? So here, you know, I'm going to kind of like figure out how many spaces are here. I'm not really sure. So I'm going to like insert a little bit of a formatting command in the code, just a little bit, right? I'm not going to go overboard on this because I could really get persnickety about it. And the way that you do that, by the way, in the string interpolation is you put in a comma, and then you can use a negative number to indicate like the minimum number of spaces from one to the next before the next column starts. And what I did last time I played with this is I used the number 14. So let's see if that works out. I'm going to run this again. And it doesn't really matter what numbers we type in here. All right, let's see how that lines up a little bit nicer. Now, I could also argue that, you know, it'd be nice if the ones columns is, you know, I'm not really too worried about that. This is just as good as what was shown in the example. So folks, this is the solution then for the lab assignment for module 5. Any questions or issues, you guys? All right, so now that we got this to work, we are going to transition over to the assignment. And I think what I'm going to do here is, I think once again, I'm going to go ahead and create a new project. And let's call it mod 5 assign or something of that nature. And we'll go ahead and create. It's below it's stuff that's sitting there. And let's go read the instructions for the assignment. So I'm going to go back here, one click, assignment. This is a 25 pointer. All right, so let's read this. It says, create a program that allows the user to fill a vending machine and purchase items from it. The program should use a list of type string, and the vending machine always vends the item that was most recently added to it. The user should be able to stock an item in the machine or buy an item from the machine. The program should inform the user if the machine is empty and when they attempt to purchase. All right. Well, those are okay, kind of weird, cryptic little instructions, but at the same time, we have an example. So this is really helpful. So it says, here, so let's take a look at the sample run. So we get a message on the screen that says vending machine. Okay, so we'll do a right line for that. And then it says, do you want to A, add item, B, buy an item, E, end. Okay, so you type A, I'm putting in a Coke, A, I'm putting in a Coke, A, I'm putting in a Sprite, and then B, bought a Sprite, B, bought a Coke, right? And why is it Sprite and Coke? Because whenever you buy something, it removes the last thing that was put in. That's the why, right? So then we remove the Sprite and a Coke, and then we're adding a Dr. Pepper. Then you buy one, and it's a Dr. Pepper because you just put it in, right? And then you buy another, and it's a Coke because that's what's left. And you buy another, and then you get a message, there are no items in the vending machine, so we have to write a situation for that. And then we end. Right? And we're going to try the sample run exactly like this to make sure that it worked. Now, a lot of different stuff goes through my head when I'm thinking about this. First of all, there's a lot of repetition here, right? You guys are picking that up, right? The fact that we're being prompted, right? Okay, and it's a user interface, most likely it'll be a while loop of some sort. Right? The other thing is we're being prompted, and then depending on what's typed in, we're responding to it. And there's a few different situations. So there's an A, a B, and an E. And there's also like, well, what if they type in something else? Right. So there's 4 options really. And here's how my brain goes. I could write a if A, else if B, else if E, else. Or I could write a switch case statement. That might be a good scenario for that. So that's what I'm going to do, right? So I'm going to do some sort of a while loop, and I'm going to put it, and inside the while loop, I'm going to do the prompt, and I'm going to do the logic for a case statement to process all of it. And now, because this is a loop that will keep running until the user enters the loop control variable or sentinel value of E, right, we'll run the loop while the entry is not E. Now, we could also, we want them to prompt at least once. I'm troubleshooting all this in my brain now, right? And I probably should be writing it down. So if I want all of this prompting to happen at least once, I could do a do while loop instead of a while loop. And that's what so I'm just kind of giving you my whole roadmap here before I start coding it. All right, let's go over to Visual Studio now. We have a blank canvas here to work with. And I always think first about like what data structures I'm working with. And we have one data structure that we haven't talked about in the PowerPoint that I'm going to introduce to you now in the form of an assignment. Now, we are told, okay, so we are told here, it says, create a program that allows a user to fill a vending machine and purchase items from it. The program should use a list of type string. Okay. And so, yeah, you can totally use that. And so what I'm going to do here is I'm going to build the program first with a list. And then I'm going to talk about a different structure called a stack, and then explain how a stack works. All right. And that's kind of like a whole different thing. All right. So if I start building this with a list, let's define the list to begin with. So let's say list, we'll use brackets here and we'll put in string. So we need to have a list of type string. You need to give it a name. I think a good name might be vending machine. Right, what do you think? That probably would work. And then we will use the new declaration and we will say list string, just like that. And are we putting anything in it yet? No, we're not. We're also going to create a variable that's a character called option. So when the people type something at the prompt, we'll capture it in that variable. Okay. We also had a little message at the top of the screen. I think it was a console write line that said, I think just vending machine, if I remember right. Kind of boring, but hey, let's put it in there. Vending machine. Right, now let's set up a do while loop. So I'm going to start with the keyword do. Right. And at the very bottom, by the way, here, we will have a while. And because our option for exiting out is going to be checking for basically the letter E, right? We're basically going to run this while loop while the option does not equal E. And because we're checking at the bottom, and really this should be inside of quotes here, let's use single quotes. All the code inside here will run at least once. The weird thing about a loop like this is you do have to put a semicolon at the end. Now here, the character option isn't preset, and I'm getting a flag down here. So you could do this. Single quotes, just blank. That's a possibility. I'm not really too worried about it because I am going to set a value here in just a moment. So inside the loop, let's do a prompt. So let's say console.write. And I'm not sure exactly what words they use, but I think it was something like this, or exactly like this. Here it is. Do you want to A, add item, B, buy item, or E, end? And of course, we're going to read that in. So option then, so that flag will go away now. We're just going to do a console.read line. And then I'm going to add a couple things to it, and a couple that we've maybe talked about and a couple that we haven't. Like one thing that I'd like to do is do a trim command. And I don't know if we've talked about this one, but a trim command is a command where just in case the user gets into the habit of typing something in and hitting a space, and I don't know if we've talked about this, like you type stuff, like whenever you type at a keyboard, you type, you hit space, type, you hit space, type, you hit a period, type, you hit enter, right? And your hands kind of do it automatically after a while. Like you type in your username, hit enter, type in your first name, hit space, type in your last name, hit enter, that kind of thing. What the trim command does is if a user types in a leading or a trailing space, it removes that from the string, so we're not processing it. So if they type a space, we want that space gone because it'll make it crash because we're reading a character and they give us more than a character. The other thing that we want to do here is I don't want to check upper and lowercase, so I'm going to run to upper to make sure that it's converted. And then what are we processing here? Position 0. This is giving me a flag. What is that saying? Nothing to worry about, basically. Now I'm gonna structure my switch statement. So here comes my switch, and I'm going to put in option here because that's what we're triggering on, so whatever they type with the keyboard. We have three cases we know about. There's case A, B, and E, and then we'll throw in a default just in case it's something else. So I'm going to say case, and then single quotes A, and a colon. And then what are we going to do here? What code are we going to type in this spot? Well, we're going to feed into the vending machine. So we want our auto type to just like do all the magic for us. So we're going to put in the end. So we want to add something to this list, correct? Is that the correct command? Yes, that is the correct command. So we're going to say add. And then what are we adding in? And this is a really interesting question, right? Because we're asking the person. Okay, so think about this. The person's being asked, which is your option? A, right? You want to add an item. What's the next thing they do? They type in the item they're adding. So what do I need to do here? I'm expecting them after they type an A to then type with the item they're adding. So I'm just going to put a read line here. Right? Does that make sense? So what are we adding? I don't know, whatever they type in. You know, it could be M&Ms, it could be Cheetos, it could be pack of gum, you know, it comes out of a vending machine. Think about it, right? So we're going to do a console dot read line right in the spot. I'm just reading in whatever they type. Then, of course, no, we typed it in, we stored it. Let's get out of here. Break, right? Then we'll add another case. This time it'll be for B. There's our colon. Sure why those parens are just floating there. And then here, let's think about this. B says buy an item. So what are we going to do when we buy an item? We're going to remove the last thing we just added. Right? So we're going to go into the vending machine. We're not going to add this time. We do want the break. You know what? I'm just going to let that type that in. But what are we going to do here instead? What was, do you guys remember the command for retrieving an item from the list? Because if we buy it, it's also being what? Removed, correct? But before we remove it, well, you know what? We can type in the remove command. Let's just do that. It's like remove. And what are we removing? And what is the syntax for removing it? Yeah, now, Alex, I see you have a perplexed look on your face. But we had an add command and we had a remove, right? But what are we removing? That's my question. And if you remember, well, okay, let's hold this thought for just a second, because before, you know, we do this, right? We want to put on the screen what it is. So maybe we just, let's do a console right line here and see how I'm like falling out of sequence and it kind of messes you up. And then what am I right lining? Well, I'm gonna just pull in from the string. Let's see how I'm building it backwards here. Let's output the last item, which would be what? If I added something, what position is it in? Yeah, that's a good question. Well, let's think about this really carefully. If I just, let's say the person just continuously adds, like they add 10 items. And then if I'm pulling out the last one, how do I find that last one in the structure? Okay, well, we have to look at its count. Remember lists have counts and arrays have length. You guys remember that little thing? Right, okay. So we would look at vending machine dot count. That would count the positions, right? Well, we look at vending machine dot count to get the number of the spot minus one, right? So we want that last position. The last position is going to be whatever the count is minus one, but that's the index value. You guys feeling where I'm going with this now? So that's how I get my index value. So I'm going to say vending machine. This is really kind of goofy. Do it this way, but this is perfectly valid like this. So whatever the last position of the vending machine is, which we figure out by count minus one, will be the index value that we're pulling from. Doesn't matter what the size is, just one way to do it, right? Now Ed is not liking that, right? And it's saying what? Vending machine is not null here. Yeah, that's true. It's not null there. But here, we have some broken codes. We have to finish this. So now if we retrieve that to put it on the screen, now we have to remove that same item. And what are we removing? Are we removing that same item, count minus one? And am I proceeding in the right way here? Right, because there's a couple little issues that are happening, and I don't know if you guys are thinking about this, because if we go to hit B as our first option, the program runs and we hit B for the first option, there's a problem here. And the problem is that there's nothing in there to remove. We didn't even think about that, right? So now I'm thinking an if statement here. So now we're gonna, all right, we gotta keep building this up basically. All right, so let's add an if statement. So here we go, like one layer upon another. So if the vending machine dot count is greater than 0, then I can output something like you bought a whatever's in that last position. That still doesn't like my syntax here, and I'm going to have to figure that out. Vending machine is not null here. Okay, well, I'll figure it out in a second. I just want to follow through with my logic, though. And then once we do that command, the else for it.
Hey, Ty, I think you're just missing a curly bracket. At the end of that line that's got the red squiggly under it.
Oh, yeah, spot on. There you go. Thank you, sir. You're looking right at it and you just don't see it, basically. Right. And you know what? We are going to want to do the remove command is not going to be here. Will actually be here. Right. Otherwise, we do have to put a message in there. And since I already have this pre-generated, you guys, I'm just going to copy paste it just for efficiency. Right. So as long as the count is greater than 0, we'll figure out what that is, put it on the screen, and then we will remove that same item using the same syntax. And I don't know if you guys remember this, but I could also store that as a variable and then remove that by name. That's a possibility too, right? But we want to remove the last item. And I'm trying to like get all this syntax here so I don't have to retype it, basically. I'll just copy that. I'm just going to paste it right there and then close it like so. What do you think of my logic here? I still have an error, and the error says, oh yeah, because I have two statements. Yeah, curly brackets. Remember what I told you about curly brackets and if statements? There you go. Perfect example. Then you start adding stuff and you forget. All right, so there's the fix. So are we good here, you think? I don't know. We're gonna have to run this and try it and see if it works. Um, can I run it now and try it? Is there anything that would prevent me from trying it? No. Yeah, I can put in A to put something in and B to see if it worked. Let's give that a shot. Let's just run it. So vending machine, do you want to add an item? So I'm going to type A and see, it's just waiting for me to type it in. So it's a Coke. And then I want to buy an item. I bought a Coke. Okay. We haven't put in the rest of it, so I have to do Control C to quit. I didn't give my way. Well, actually, I could have typed E. E would have worked and it would have popped me out, I think, but maybe not. Let's write the other cases now, you guys. So let's do a case where we're going to do E. What happens with E? Well, pretty simple. Here's my code for it. No, we're not console write lighting. We are going to just say thank you and break. But I think we also need a default. So let's put in a default. What if they type something other, right? We don't know. And then you want to have a little message there also. Here are my messages. Invalid input and a break. Now, believe it or not, that this accomplishes all of it, right? And this is using a list. So I'm going to go ahead and run this again. And I'm going to see if I can replicate what they did here. So let's see if I can hold the console right over. So we're just going to follow the same inputs. We're going to go A and Coke. A, Coke. A, Sprite. And then B, we bought a Sprite. B, we bought a Coke. All right. A, Dr. Pepper. B, you bought a Dr. Pepper. So far, so good, right? Then B, we bought a Coke. And B, there are no items in the vending machine. So it looks like my logic is working great. If you guys are picking up on that. And then let's see if we can do an E and we end. Right. Now, what we didn't try is putting in a wrong entry. I'm not really so concerned with the wrong entry, but I'm concerned with the right responses for what we're supposed to get. So this is doing it using a structure called list, right? So let's go back to the code really quick. I am going to terminate the program run here, but there's pretty much all the code. I can zoom out so you can get it all at once if you're screenshotting or whatever, but we use the list structure here to do it. Now, interestingly, I have an alternate version here on the screen that I'd like to share with you that uses a different data structure. And this goes really quick. The alterations to the code are minimal, but it works a little bit more efficiently in a structure where it's last in, first out. So there's a special type of array collection. I did close the slideshow called a stack. And here's the analogy that I always like to use because this is how I internalized it. So when I was in, I was working on my bachelor's degree, and one of the required courses in the bachelor's degree, like after you did like a couple levels of programming, you had to take this weird class called data structures. And we were all like, what the hell is this about? And what it was is they taught you about things like this, including arrays, but much more complicated structures, ultimately multi-dimensional arrays and stacks and queues and collections and all sorts of stuff. But we started learning about this thing called a stack. And a stack is a really interesting data structure because the way that it works is it's kind of like when you go to like a buffet, like, I'm trying to think of one of those buffets, like Golden Corral or something, like one of those places. I don't know if you guys have ever been. Um, Not highly recommended, but whatever. It is what it is, right? If you want to load up your plate a lot, I mean, it's the place to go to. But at the end of the buffet where they put the dishes, they have this device that's spring loaded, and they take all the dishes and they store them in a stack inside the spring loaded device. And the first dish that you put in will be the last dish that you take out. Right? So first in, last out, or last in, first out. So in other words, if I'm trying to get that first dish, the only way to get to it is to take all the other dishes that came after it. So every time I get a dish, I add it to the stack. The rest of them push down, and we get this really weird terminology that goes with the stack structure. So a stack structure is basically like a list. It's dynamic in size, but you can only add and remove items to the last position, right? And so when we add stuff to the stack, we say push. We are pushing stuff onto the stack. And then when we remove something from the stack, we simply say pop. We're popping it out and pushing it in. So what I'm going to do right now is I'm going to quickly rewrite this code. I'm going to leave the list language basically in place, right? So you can see it, right? And if you wanted to compare with it, you can. You do not need to make this alteration, by the way. I'm just showing you the syntax for it and how quickly it is to kind of change to a different structure, right? So I can name it the same thing, but I'm just calling it a stack. Notice you got the strings, you have the brackets declaring it all. Those declarations are all the same, right? The prompt is still the same. When we read in the information, it still reads in the same, right? There's no change. We're going into position 0, right? In that case. Okay. So next we go to the statements where we read in the information. Do we need to change the read line? No. When it comes to changing these statements, and the reason I'm showing you this is because the statements for basically adding things and removing things are essentially different, but much more simplified, and I think easier to understand. When you get that concept of push and pop, it resonates a lot better. So for example, when I'm adding stuff to the stack of dishes, if you want to keep using that analogy in your brain, I'm using push instead of add. So I would just say push. But that one stays the same. So it'll read it in, and we're pushing it onto the stack, right? Then when it comes to removing stuff, this syntax is significantly cleaner. Instead of going like what's in the position, which is the length minus 1, all that stuff, I can just remove all that. And in fact, here, instead of removing it, let's kind of do it like this. Let's do a comment, and then I'll copy the line and just alter it. That's what I should have did up there too, but oh well. So here, instead, I would say vending machine pop. And actually, it's a capital P. Right? So vending machine pop removes the last item, pulls it out. And we also, and this is kind of the beauty of this one, you'll notice that we don't need to remove it because pop pulls it out, reads it, and removes it all at the same time. Right. So let's look at the efficiency of that code. And so if you're wondering, okay, so why do they have all these different types of collection types, and why do they, kind of do that? Well, the reason is because it's basically some of them work a little bit better in certain situations especially given the scenario that we're talking about, which is the last thing that went in is the first thing that comes out. Like you don't have a choice when you walk up to a vending machine, but in this, for this one, you don't. What I'm going to do here is I'm going to put back the add command. We do the console dot read line, just in case you want to have it there for comparison, right? But that's the difference. That's the only differences in the code. Otherwise, let's run it just to prove that it's okay, right? So we can add a Coke. We can add a grape soda. We can buy grape soda, right? And we can buy a Coke and buy again. Now it's empty, and then we can exit. And we're good. So very simply, converting it to a stack structure, right? So it's one of the things that we didn't even lecture on. Pretty easy change. But notice how, it's got different methods to it. And so, I'm showing you both here as kind of a point of reference. And also I'm taking the opportunity to teach you one other collection type really quickly, and efficiently without giving you 10 PowerPoint slides on it with all the methods, you know what I mean? So sometimes it's easier, like when you get the concepts, to just kind of roll with the code and oh, check this one out. This one does this. Oh, that's kind of cool, right? And a stack is a fairly easy data structure to understand because of that analogy of the stack of dishes, right? In truth, when you're dealing with stacks, they do have methods where you can pull stuff out of the middle or whatever, but generally speaking, you push onto the last spot or you pop off the last spot. And you can see how that actually created a little bit cleaner code here. All right, so that's the solution to this one. And you know what? Our timing worked out great. So we got to both the lab and the assignment, and we did 2 different versions of the assignment and all lecture materials all in one night, making us not feel guilty for having a turkey dinner on Thursday, right? So, all right, folks, I'm going to stop the recording here.